Hello students, welcome to today's class. So today we are going to continue on chemistry, Graham's law of diffusion. Now, Graham's law is one of the interesting topics you need to master well in order to solve exercises on it because it always comes out in exam. Like this one is JAM, written last 2 years. So we have a question on the board. 20 cm cube of oxygen diffused through a porous plug in 50 seconds. How long will 80 centimeter cube take to diffuse through the same porous plug under the same conditions? Now, before we solve this, let's highlight on Graham's law. Of course, we know that Graham's law states that the rate of diffusion of gas is inversely proportional to the square root of its vapor density, provided that the temperature and the pressure remains constant. Now, when you put it in a mathematical form, we have it as rate of diffusion of gas inversely proportional to the square root of its vapor density, where R is the rate of diffusion of gas, D is the vapor density. Now we have rate of diffusion of gas equal to constant 1 over square root of D. So rate of diffusion of gas is K over square root of D. So if we make K the subject of the formula, we have K equal to R times square root of D. Then are these very constant, that's the temperature and the pressure being constant, the rate of diffusion of gas times the square root of vapor density will always be constant, no matter the gas that is involved. So when we have two gases, maybe we said gas 1 and the gas 2, we now have equation that R1 square root of D1 now becomes equal R2 square root of D2. So we might decide to bring all R this side, then we have the density the other side. So in doing that, we have R1 over R2 equals D2 all over D1. You can combine the roots under the rule of third. So we have R1 over R2 equals, we have square roots D2 over D1. Now, if you have this very formula, we can also impute molecular mass. Molecular mass has a relationship with vapor density. Now, we all know that vapor density is half of molecular mass. And with this relation, we can now say that R1 over R2 equals, here we have D2. Now D2 automatically becomes half of M2. So we have half of M2 all over half of M1. So at this point, we can cancel out this half. We have that R1 over R2 equals square root of M2 over M1. Then you now have another formula. If you combine these two formulas, we have a general formula. This first one, that rate R1 over R2 equals square root of D2 over D1 equals square root of M2 over M1. Then we have generated a formula. Then again, we know that rate of diffusion of gas is equal to volume over time taken for the diffusion. So with this very formula, we can solve this exercise. Now we have 200 cm cube of oxygen. That's the volume of oxygen. Hence we have volume of oxygen given as 200 cm cube. Now, diffuse through a porous plug in 50 seconds. Time of diffusion of oxygen, we have it as 50 seconds. Then how long will 80 cm cube of methane take to diffuse? So the volume in question, of which we are now looking for each time to diffuse, is 80 what? Cm cube of chlorine. That's the volume of chlorine. Volume of methane. Volume of what? Methane. So the volume of methane here is what? 80 cm cube. Then we are now looking for time of diffusion of methane. Then with this, we can now decide to get the rate of diffusion of oxygen. That is volume of oxygen over time of oxygen. Then rate of diffusion of methane, volume of methane over time of methane. Now let's take the time of methane to be T as the answer. Now we are to get the value of T. So with this, volume of oxygen over time of oxygen will give us what? Rate of diffusion of oxygen, which is VO over what? Over TO. So with this, we have 200 divided by 50. Then we also compare these two, volume of methane over time of methane. We have rate of diffusion of methane, which will now be V of methane over time of what? Methane. So V of methane now is 80 over T. So at this point, we've got the rate of diffusion of oxygen as well as the rate of diffusion of methane. So let's substitute using this R1 over R2. Then we also know the molecular mass of those gases. Like we have molecular mass of oxygen. You know, oxygen is a molecule, that is O2. So we have oxygen atomic mass is 16 times 2. We now get its molecular mass, which is 32. Then the molecular mass of methane. Now to get the molecular mass of methane, we have carbon and 4 atoms of hydrogen. Now the mass of carbon is 12. We have hydrogen. Atomic mass of hydrogen is 1 times 4. Then we have 4. So the molecular mass of methane automatically becomes 12 plus 4, which is 16. Now we can now go back to substitute in the given equation, the equation we derived already. So we have R1. Of course, we are going to use 1 to be oxygen, 2 to be methane, or vice versa. So if 1 represents oxygen, automatically we have rate of diffusion of oxygen over rate of diffusion of the second gas, which is methane, which will now be equal. We have the molecular mass of the second gas, which is square root of molecular mass of the second gas, which is methane, then all over the molecular mass of the first gas, which is oxygen. So at this point, we do the substitution. Rate of diffusion of oxygen. We've got that as 200 over 50. So we have here 200 over 50 divided. We have rate of diffusion of methane. Now, rate of diffusion of methane is 80 over T. So we have here as 80 over T, which will now be equal. The molecular mass of methane, we got that as 16 here. We have 16 over. We have molecular mass of oxygen. We got it as 32. So at this point, we solve to obtain the value of T. Now, here is 50. 50 divides itself 1. 50 divides 200. We have 4. So here we have 4 over 1. So 4 over 1, when you change this division to multiplication, we now have what? T over 80 equals square root of 16 over 32. Okay, we can divide 16. 16 divides 16. We have 1. 16 divide 32, we have 2. So at this point, 4 times t. Oh, we can still divide further. 4 can go into 4, 1. 4 can go into 80, we have 20. So at this point, we have t all over 20 equals square root of 1 over 2. Finally, we have t over 20 equals square root of 1 is 1. Square root of 2 is square root of 2. Now we make t the subject. T we times root 2. We have root 2 times t. 20 we times 1. We have 20. So if you divide both sides by coefficient of t, which is root 2, then we now have that t is equal to 20 divided by root 2. Now, let's punch 20 divided by root 2. So if 20 divides root 2, we are going to get 14.14. So 14.14, but approximately, I think we have 14. We check if we have it in option. Remember, should be measured in seconds. 14 seconds. Now, let's get back to the options. We have option A, 40, option B, 20. Wow. The option C now becomes the correct answer. So, we continue next time. So, you read up, subscribe, and share to others to learn.